Biologists, I hope you're enjoying our discussion of Chapter 42. We've been talking about the cardiovascular system. We've talked about how our heart and lungs kind of work together to exchange material with our environment. And we've talked about some anatomy of our heart, some of our valves, some of those different components, our different atria and ventricles. We've talked about some of the major arteries and veins that are connected to our hearts. Now we're going to talk about what a cardiac cycle is. So our heart beats in this rhythmic pattern of beating and relaxing. When the heart is contracted, it's pumping, and that's called systole. That word might be pronounced a little bit differently than it looks, but systole is when the heart is contracting, blood is moving. When the ventricles relax, blood is filling back in. That's called diastole. Blood is filling the chamber. And cardiac output refers to how much blood, the volume of the blood that the ventricle is pumping in 1 minute. So that can be affected by your heart rate, right? If your heart is pumping faster or slower. It can also be affected by the stroke volume, so how much blood you're pumping in one single beat of your heart. Although for most of us, a normal output is going to be 5 liters per minute, which is probably close to the amount of blood that you have. If you've ever listened with a stethoscope to a heartbeat, it has the sound of lub-dub, lub-dub, and that sound is when what you're hearing, you're actually hearing the opening and closing of the valves. So that first lub is when the blood is recoiling against those AV valves that have closed and the blood is recoiling against them. Then the second dub is when the semilunar valves close. And if you've ever been told you have a murmur, if you've heard a murmur, that is if there's a defective valve and the blood is spurting backwards instead of recoiling against a closed valve. Your valve is a little bit leaky, so the blood is spurting through it backwards. That's what creates a heart murmur. For some people, a heart murmur is nothing to worry about. For some people, it might be a symptom of something more going on. And a cardiologist would be able to help you if that is something that you need to follow up with. Okay, a lot of the cells in the cardiac, or a lot of cardiac muscle cells, are autorhythmic. That word means that they are going to contract without any signal from a nervous system. You could actually put in a petri dish, see heart muscles contracting independently of any sort of nervous system. The sinoatrial node, or the SA node, is sometimes called the pacemaker because it sets the pace. It sets the rate and the timing for the cardiac muscle cells to contract. And it does this with electricity. It generates electrical impulses, and then those impulses pass to other cells through the gap junctions in the heart. That is something that we talked about last semester, so if you need to go back and review what a gap junction is, this is a good time to pause and review that. So there's electrical impulses passed through other cells of the heart through gap junctions, and this causes both cells to contract at the same time, and the impulses that travel through the cardiac cycle can be recorded on an EKG, which is the German spelling for electrocardiogram. So first, the sinoatrial node passes those signals through to the atria, and you get this little bump on your EKG. The AV node in the wall between the right and left ventricle will delay those ventricle impulses a little bit, which allows the atria to completely empty and make sure that all the blood is filling into the ventricles before the ventricles contract. The signals are delayed down the AV node, then bundle branches take the signal down to these ventricles, and their Purkinje fibers stimulate the ventricle walls. So you end up with this stimulation. So why is it important that the AV node delay the electrical impulse moving from the SA node and the atria to the ventricles? I just gave you that exact answer word for word, so go back and review that. Make sure you can answer that question. The sinoatrial node does receive signals from the nervous system, and there are two different divisions of the nervous system that are involved in setting the pace of your heartbeat: the sympathetic division and the parasympathetic division. The sympathetic division is going to increase heart rate by speeding up the sinoatrial node. Sometimes a sympathetic division is referring to as like the fight or flight response, and helps you move quickly. It has your muscles respond quickly. It's going to be part of that sympathetic division, increasing your heart rate. Okay, excuse me, I had to take a break and cough for a minute. So the parasympathetic division slows down the heart rate. Sometimes this is called like the rest and digest part of your brain system, your nervous system. It slows down the heart rate when you're ready to relax. Cold temperatures can also slow down the heart rate. High temperatures can increase the heart rate. You might have noticed when you have a fever and your body is a little bit warmer, like if it's just a degree or two warmer, you might have an increased heart rate. Okay, we're going to come back in our next video and talk about different capillaries, different arteries and veins, and our arteries and veins and capillaries and how they're made or what they're made of. And I'll see you in our next video. Bye.